Freeze did this lesson. When you first were talking about limits and you're finding the limit of the value, how we did, how when this was the limit, the formula, one of the formulas you could use was this. Do you remember that? And then we did the one where you had x plus h. Okay, this is, all this is the limit is the same thing as the derivative. Okay, so this is set up like this, but what you're trying to do is find the derivative of f of x. Well, f of x is just this function. So now instead of actually having to do the limit, you now know the new rule for this. So what's the rule for that? How would I find the limit, which is also the derivative? What do I do with 1,000? Goes off in front.
Wait, I'm confused. How did you get from there to there?
Okay, so when we first, 2 weeks ago, I don't know, when you learned limits, this was the very first way you learned how to do it from Miss Freeze.
Derivatives?
Yes, how we started talking about the limit was the derivative, and then we also did the one that was like x plus h.
Yeah.
Okay, so this was one of the ways, and then I said, well, this way's easier because as h goes to 0, because you don't always know what it is this value. Okay, this is set up like this. Because this has f of x minus f of a, because that's 1, and 1 to the 1,000th is still 1, over x minus a, which was x minus 1. So this right here is my f of x. So you have two ways you can find derivatives. You'll first learn how to do it doing limits, but now you know the power rule, so it's just connect. The whole point of this problem is to connect your brain to mean those are the same thing. So this is really 1,000 x to the, okay, why did they pick 1,000? Because they know you're not going to do this like this. Okay, but this would be your derivative. Alright.
So the limit is the same thing as the derivative?
This limit formula. Yes, actually what you're doing is you're finding where the, yes.
Okay.
In a function form. Where you're finding that value is where you're finding, it's, when you're thinking of limits, you're thinking of add that value. Okay? This is a derivative of just a function as a whole. I don't have a value given. Like for this,
But isn't it 1 is the value?
this was the limit as it went to 1, yes. So what I need to do is actually I need to finish this problem out. Because we actually have to find what it is at 1. Okay? Sorry.
So the derivative is where the two limits meet.
The left-hand side and the right-hand side limit meet at that point, yes.
And that's the derivative.
Yes. The limit of that is where they meet at the derivative, yes. Okay? So like, the derivative, if you don't know what your value is, it's your function, your equation, we know the value is at 1. So what's 1 to the 999th? So 1. So this would be, the derivative at 1 is 1,000. Like if we wanted to find where's the derivative at where x is 2, then I'd put 2 in for x. Okay? But you could have done it here just as easily, because you're not going to, because it says as x approaches 1, but it wouldn't have made the denominator 0. So we had to change it because it made the denominator 0. That just really confused your heads. That wasn't my
I
goal.
would just plug in numbers and approach one.
Could do that. Yeah, like you could have done like 1.1 and then like 0.9 and like make sure they're meeting the same number, which would have been 1,000. Yes.
But that's how we should do it. You're not supposed to.
You're not supposed to use calculator, correct. The whole point of this problem was for you to draw the connection between, oh, we were talking about limits and as they approach a number, now we're learning a different rule. Okay, those are the same thing. That was the point of it. Get you thinking here. Okay, December 12th, which is a Wednesday, not next Wednesday, but the Wednesday after, We will not have morning class because I have to go down to IU to be certified so you guys can still do your children.